Good afternoon, student. Then let us move to the next topic. Differentiation by S. That is a multiplication by the t. If f of s is a Laplace transform of f of t, then differentiation is S is a complex frequency domain corresponding to multiplication by the t in the time domain. Here L t f of t, the function equal to minus d f of s by ds. Here minus, from the definition of the Laplace, f of s equal to 0 minus infinity, because the d is minus, no, minus d f of s ds. You take 0 minus infinity, it is 0 only, 0 to infinity, but here 0 minus infinity, f of t est dt, basic definition of the Laplace. Both the sides, differentiating both the sides with respect to the s, d of s, d f of s ds, 0 to infinity, f of t d by s est dt. Just you separate the term, 0 to infinity f of t one side, next minus est, that is minus t est dt function. Here 0 to infinity t f of t est dt, that is a minus L t f of t, the function of t f of t, minus L t f of t as per the definition. Here L t f of t equal to minus d f of s by ds is proved. Why minus? Because of the t. T is a minus d f of s by ds proved. The next complex translations. Next properties. If f of s is a Laplace transform f of t, then complex translation property. If s minus a, that is L e a t f of t, but here plus s minus a. Suppose minus s plus a, but here plus is there, that is f s minus a. Here where a is a complex number, L e a t f of t, that is f s plus a. Just now told, no, minus a t, that is s plus a. The Laplace transform e a t f of t is the function of L e a t f of t, 0 to infinity e a t f of t est dt. 0 to infinity f of t e minus outside s of a t common. The t is a common, e a t e s t minus s a t dt f s a. E a t f of t is f s minus a. Suppose e minus a t f of t, f s plus a. Proved. The next shifting theorem, there's real translations. This theorem is useful to obtain the Laplace transform shifted to or delayed function of t. If f of s Laplace transform f of t, then Laplace transform of the function of delayed by t, that is L f t minus capital T, small t minus capital T, e minus ts f of s. By the definition, L f t minus t, 0 to infinity e s t f t minus t dt. As a function shifted by time t, the lower limit integration can be changed from 0 to t. But here 0 to infinity, you change 0 to t capital T. Next L f t minus t, t to infinity. Why t to infinity? Because of 0 to t. You take t infinity e s t f t minus t dt, this function. Here tau is nothing but tau, change in the time, that is a tau t minus t. T equal to capital T, tau equal to 0, t equal to infinity, tau equal to infinity. Here L f t minus t, 0 to infinity, e minus s, tau plus t, tau plus t, f tau d tau, 0 to infinity e s minus s tau, e s t, f tau dt. Just to change outside e s t, 0 to infinity e s tau f t d tau. It is a f of s. It is a f of s from the definition. It means L f t minus t e s t f of s proved. Okay. Initial value theorem. Next. F Laplace transform is very useful. Find initial value of the time function f of t. Thus f of s is a Laplace transform of f of t. F of 0 plus t tends to 0, limit t tends to 0, f of t, limit s tends to infinity, s f of s. That is a theorem. This theorem is proved. The only restriction that f of t must be continuous or most of step discontinuity t equal to 0. The considered Laplace transform of the real differentiation L df of t dt, that is s f of s minus f of 0. Why? That is 0 to infinity change, s f of s minus f of 0. Taking s tends to infinity, both side limit applying limit L tends to infinity, L tends to infinity. Consider left hand side above equations. Limit S tends to infinity, L d of t by dt, S infinity, 0 to infinity, est dft dt. What is est dt? That is a function of limitation. It's 0. As the limit S tends to infinity, est equal to 0. 0, left side 0. The remaining right side, L S tends to S f of S, f of 0. What is 0? F of 0 equal to limit S tends to S f of S. Here f of S function f of t continuous f of 0 equal to f of 0 plus the initial value f of t is 0 plus limit t tends to 0 f of t, the S tends to infinity, S into S f of S. Same thing in final value theorem. Similarly, initial value, the Laplace transform of also useful. Find the final value time function f of t. Thus, f of s is the Laplace transform f of t. Then final value theorem states that limit t tends to infinity f of t, limit s tends to 0, s f of s. Only restriction that the roots of denominator polynomial s f of s, there is a polynomial f of s, has the negative or zero real parts. Here L df of by dt s f s minus f of 0. Taking limit both side s tends to 0. Previous s tends to infinity, here s tends to 0 because of we calculate final value. We take s tends to 0 both the sides. Only consider left side. S of 0, 0 to infinity dft dt est dt. 0 to infinity dft dt dt. The limit s tends to 0, est equal to 1 because of 0, e0 equal to 1. F of t, f of 0 minus. Putting the value equations, f of t, f of 0 equal to s tends to 0, s f of s 0. This theorem is proved. The remaining next video.